In this lesson we're going to look at more problem solving using Pythagoras. So in this series of problems we're going to look at examples where the triangle is not just a right angle triangle in front of you. There may be something else to deal with. For example, here we've got to calculate the length of the roof where we have a gable end, if you like, and we're looking for this length here, which is kind of attached to a rectangle. Now, the problem with this question is that we need to separate the right angle triangle and get the dimensions of it. So if we think of just this part here, to get this is all we're interested in. We're only interested in the right angle triangle part to use Pythagoras. None of the rest of it really matters except to get the sides. We can use other bits to get the side lengths. So if you look at this bit along the bottom, then this bit is exactly the same, the bit down here. This is also 4.3. So I would encourage you to draw a right angle triangle out and put 4.3 along the bottom. Now the bit up and down the side here is calculated by doing 7.6 subtract 5.1. What do you add to 5.1 to get all the way up to the top? And that comes to 2.5. So basically what we do here is we've got a wee right angle triangle, draw it out, put the 2.5 in and the 4.3 and use pure Pythagoras to get the diagonal or the hypotenuse. So first things first, write the formula out, c squared equals a squared plus b squared. I'm going to use an r here because we're working out the length of the roof, so r squared is equal to, it doesn't really matter which way around you put this, 2.5 squared or 4.3 squared plus 2.5 squared. Then if we work 4.3 squared out in the calculator, 18.49 to the same as the 2.5 squared, and then add these together, we're still r squared at this point, and that comes to 24.74. And finally, to undo this and just to work out the length of r, you need to square root your answer there. So for the square root 24.74, we get roughly 5 meters rounded. And that's it. Okay, let's do another example. So, gold chains are displayed diagonally on a square board of side 20 inches. Calculate the length of the longest chain. So there's a couple of things to notice there. The fact it says square means that this is 20 inches by 20 inches up and down the way. So we've got 20 inches up here as well. And the other thing is we're looking at the longest chain. Now the longest chain is this, we've got a different highlighter colour. The longest chain is this one here, all the way up there. So if we're trying to calculate the length of the longest chain, we're kind of using a triangle there, down here, along and up. So that could look like this, I suppose. Doesn't really matter which way down the triangle goes, you've still got the same idea. So the triangle's 20 and 20 up and down the way. So 20 inches by 20 inches. We've got to work out the longest chain. Okay, it's that way, but it's the same length this way. So we just do Pythagoras again. So c squared equals a squared plus b squared. C squared equals 20 squared plus 20 squared. Now that's 400 plus 400. So that comes to 800. And then if we square root our answer, square root of 800 gives us 28.3 inches for the length of the longest chain.